Hey guys, hope everybody's doing well. This is Dr. D. I'm back. We're talking about statistics again. Today I wanted to walk you through a practice problem. We've been talking a little bit about data, elements of data, and observations, variables, how to categorize those using data scales. You can check my other videos if you want to kind of see a walkthrough there. But I have a practice problem here that I'd like to go through and talk to you a little bit about it. So this is the one we're going to be working on. The U.S. Department of Energy provides fuel economy information. This is taken from Anderson, Essentials of Business Statistics is I think what it's called, but I'm going to work it out. So yeah, the U.S. Department of Energy, they have information for a variety of motor vehicles. A sample of 10 automobiles is shown in the table below. Here's the table. This data was taken from the Fuel Economy website in 2008. The data show the size of the automobile. There are three categories: compact, mid-size, or large. The number of cylinders in the engine, the city driving miles per gallon, and the highway driving miles per gallon, as well as the recommended fuel. And then the question has a bunch of different parts. It's just asking us some information about describing the data set, talking about what features it has. So that's what we're going to look at. The first question, part A, is how many elements are in this data set? So come on over here. If you remember, an element is one thing that we observe, right? We're measuring, when we collect data, we take observations, and an observation is a measurement of a bunch of variables for a given element. And so here we have a bunch of cars, right? And it tells us in the question that we have 10 of them, a sample of 10. But we also can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 elements in this data set. Part B is asking us how many variables there are. I actually disagree with the textbook answer here. The textbook says that there are 5. 1, 2, 3, 4, 5. But I think the car should also be one, so I'm going to say 6. And I teach this stuff, so I get to decide. Yeah, so the reason I think so is that if you ever use software that's going to read these in, it's going to read all of these as variables. The name of the car matters. Sometimes people think of a unique identifier as not a variable. I find that personally it's easier for me to think of them all as variables. Yeah, so there we go. So there are going to be 6 variables. And those 6 are car, size, cylinders, city miles per gallon, highway miles per gallon, and fuel type, which is hidden. I suppose I might as well just uncover that. Okay, part C. Which variables are categorical and which are quantitative? Now, if you remember, we had 6 different scales, and we had 4 different scales. Sorry, and we could break those into 2 sets of 2. 2 of them were categorical. Those are essentially variables you can't do math on very much, right? You can put them in order, maybe you can't put them in order, but you can't subtract. You can't meaningfully subtract them or multiply them or divide them or add them. What that means essentially is that even if you can put them in order, the distance between any 2 neighboring values is not constant, right? So that would be like excellent, very good, good. Like you can put those in order, but the difference between them doesn't really make a lot of sense. Even stars, 5 stars, 4 stars, 3 stars, are rated on a scale of 1 to 10. A lot of times the distance between those is not constant. So that would be categorical data. Quantitative data, on the other hand, is stuff you can add or subtract. So which ones are categorical? I think certainly anything that's like a word is going to be categorical. So that's going to be car, the name. The size of the car is categorical as well. And then cylinders, no, that's a number. This one has twice as many cylinders as that one. Miles per gallon, those are numbers. And then fuel, the fuel type is going to be categorical. That leaves the rest to be quantitative, right? So quantitative, the other 3. Cylinders, city MPG, and highway MPG. All right. Okay, next, part D. What type of measurement scale is used for each of these variables? Well, if you remember the categorization of the scales, then you know that these 2 have to be either nominal or ordinal, and you know that these ones have to be either interval or ratio. If you don't, well, you can try to remember what they mean. So nominal ones, nominal scale, These are any that you can't even put into order, right? Like your name or your state of origin, right? You can put, I mean, you can put them in alphabetical order or the order admitted to the union, but there's no one order that it makes sense to put them into. Okay, so which ones are nominal? Well, the car is nominal. Size we can put in order, right? The smallest ones are compact, mid-size is bigger, and large is bigger than that. Fuel you almost can, but diesel gets in the way because it's not clear. You could say it goes regular, premium, and then premium plus or whatever, but diesel, it's not clear where to put that. So those are the ones that have a nominal scale. Next is, oops, not that one. Next is ordinal. Now these are ones that you can put in order, but you can't add or subtract or multiply or divide. And that's just going to be size. Because we can add and multiply cylinder city miles per gallon and highway mile per gallon. Okay, the next scale is interval. An interval are ones where the zero is arbitrary. What that means is you can't multiply or divide it. You would never say percentage changes are twice as much. Those are actually pretty rare. Stuff like temperature, calendar year, standardized test scores, but they're not that common. And in fact, in this case, none of these are interval, right? Because we can multiply all of these, right? So we have our last one, which is ratio scale. That's going to be cylinders. It's going to be city miles per gallon and highway miles per gallon. That's because we can talk about getting, and you'll see this in car commercials too, right? This one gets twice the miles per gallon of this one. Not exactly, but close, right? Almost twice. Similarly, here we have the Hyundai Elantra gets almost twice the highways miles per gallon, or city miles per gallon as the Chrysler 300. The Audi A8 has 3 times as many cylinders as the Ford Focus. It's like 3 engines just. And you can imagine that you would probably prefer, if you're racing, to be driving an Audi A8 versus Ford Focus. More cylinders, more explosions. Okay, what else do we have here? That was part D. Part E, what is the average miles per gallon for city driving? Okay, now the way to find the average is to add them all up, right? Add all these numbers up and then divide by however many there are. In order to do that, I'm going to use Excel because I find that it makes such practices faster. You can totally do it by hand. I just don't want to, so I'm not gonna. Let's see. I want to get it so I can see my. It wants to know city driving, right? City miles per gallon. So I'm just going to enter these manually. I got 13 for the Audi A8, 17, 16, 13, 24, 25, 17, 15, 21, 21. 10 numbers. Now in Excel, there's a relatively easy way. You can just select them all, and it'll show you the average down here. Another way to do it is to use a formula equals average. That'll tell you. That's the final way, is add them all up. Put that here. That's the sum formula. If you add them all up, you get 182. How many are there? Well, we already figured that out for part A, right? There's 10. And then the average is going to be the sum divided by n. That gives you 182 divided by 10, 18.2. So 3 different ways to get that. You can do it by hand if you want. You're certainly welcome to add them up by hand with a calculator. You might make a mistake, but that's okay. People make mistakes. So the answer to part E, let me pick a different color. E, the average city MPG equals 18.2. There we go. On average, how much higher is the miles per gallon for highway driving as compared to city driving? Well, in order to figure that out, we're first going to need to figure out what the average is for highway driving. Now I don't want to get my data mixed up. You'll notice that I often just start typing stuff in here, but I want to keep it clean. So, city MPG, highway MPG. I don't want to get these mixed up. So now they're labeled. And I want to kind of keep the stuff that I did here out of the way. Okay. So, entering our highway miles per gallon. And just double check that. 19, 25, 25, 18, 33, 33, 26, 22, 31, 29. Perfect. Okay. Now, on average, how does this work? I already calculated it here, so I can copy and paste that. I just use Control-C, Control-V to copy and paste. Another way to do it is Control-R, which fills to the right. And that's my average highway miles per gallon. That's not what the question is asking, though. The question is asking, how much higher is that compared to city driving? Well, all we got to do is take the average for highway driving and subtract, right? So here if we want to keep all our stuff tidy, we can have average highway MPG, average city MPG, highway MPG is this one, city MPG is this one, difference equals this minus this, 7.9 miles per gallon. So that's how much higher the miles per gallon is when you're driving on highways. Part F. I'm going to use abbreviations here. X bar highway minus X bar city equals 7.9. That's the difference. And that's just a short, X bar is a short way of saying a sample mean. It's a symbol for sample mean, and I have these little subscripts to indicate what I'm talking about. Okay, what percentage of the cars have 4-cylinder engines? This one we can do without needing to resort to math, I think. Or I mean to Excel. So let's see. To find the percentage, we want to know the number of cars that have 4-cylinder engines. We're going to call that X. We want to divide that by however many there are in total. We'll call that N. We already know what N is, right? There are 10 cars. So how many are there that have 4-cylinder engines? Well, I see the Ford Focus, the Hyundai Elantra, and the Toyota Camry. So that's 3. So 3 divided by 10 is 30%. Ta-da! That's how many have 4-cylinder engines. Similarly, we can solve what percentage of the cars use regular fuel. H. X divided by N. In this case, X here was 4 cylinders. Here, this is regular gas. So X is just a placeholder we use for whatever number we want. N is our sample size. We have 10 again. So how many use regular fuel? We have 1, 2, 3, 4, 5, 6 by my count. 1, 2, 3, 4 don't. That's another way to double check. So we have 6 divided by 10. That's 60%. So there you go. 60% of these cars listed use regular fuel. Okay, so that's how we can play with data a little bit, how to enter it into Excel and solve some stuff in Excel, how to understand what the variables are and what measurement scales they use. I'll be posting more practice problem solutions soon, so stay posted. And if you have any questions, as always, just post a comment or send me an email. Appreciate it. Thanks, guys.